Dictionaries are a built-in data type in Python that hold pairs of a key, which is what you use to look something up, which is what you use to look up a value, and the corresponding value. The way they're written, both in code and displayed as values, uses curly braces and colons to separate the key and the value. Let's take a look. This assignment statement of the name numerals to a dictionary is building a new dictionary out of 3 pairs separated by commas, and the commas are separating this key value pair from this one from this one. In this particular dictionary, all the keys are strings, all the values are numbers, but it didn't have to be that way. You could use numbers or strings as keys or values. Once I've created numerals, the most common operation I'll perform is to look up a particular value based on its key. Now with dictionaries, we're using the same item lookup syntax as we would for a list, but we can't just put an index in there, like I want the element at index 0. That will give me a key error. For a dictionary, the only values that I can put in the square brackets in order to look them up are keys. I can look up v, which gives me the number 5, which corresponds to v, and I can look up x, but I can't look up x-ray because it's not in there. I also can't look up keys by their values. You might want to look up the key for the number 5, but that doesn't work either. Dictionaries go only one way. Dictionaries are also sequences. In particular, they're sequences of keys. So if I build a list out of numerals, I can see all of the keys. And that means I could use numerals inside of a for statement to go through all of the keys. What if instead I wanted to go through all of the values? Well, it turns out that's possible too, using the following syntax. Numerals dot values, and then you need these parentheses. What you get back is a strange looking beast. It says dict values 1, 5, 10. This is a type of sequence, although it is not a list. So you can't do everything with this that you could with a list, but you can do many things, like for example, you could sum them up, or you could iterate through each one using a for statement. If for some reason you really need a list, you could call list on numerals.values, and that would give you a regular old list instead of a dict values, which is a special kind of sequence only related to dictionaries. Much like a range is a special kind of sequence only related to integers. Dictionaries can be constructed with no elements, one item, or multiple items, as we've seen. It's also the case that the values themselves can be arbitrarily complicated. Just like the element of a list could be another list, the value in a dictionary could be a list. Like so. Oh, except I need to actually put a quotation mark there. And you could have one value be a list and another value be a string. That would work just fine. Now if we call this thing D, I could get the element for key 1, I could get the element for key 3. I could also figure out how many elements there are, 2, and that describes the fact that there are 2 keys. The length of the values corresponding to those keys might vary. This value has 2 elements because it's a list. This value has how many elements? Well, it's a string with 5 letters. Now there are 2 important restrictions about the keys of a dictionary. One, you can't repeat a key. If I said 1 is first and 1 is also second, what I would get back is a dictionary with the key 1 only once. So if I want to associate a key to 2 different values, I should have one key associated with a list of those values. And the second restriction is that the key itself cannot be a list or a dictionary. This gives me an error, unhashable type list. Unhashable is a technical term in computer science that I wish I could teach you about, but I have to leave something for 61b, so you'll learn about it there, or you can read about it on the internet. The reason I reached this error is that I tried to use a list as a key, which is not allowed in Python. Similarly, I cannot use a dictionary as a key. I'll get the same error. But it's totally fine to have a dictionary be a value. Anything can be a value. These restrictions only apply to the keys. So the limitations, again, are that dictionaries are collections of key-value pairs, where a key of a dictionary cannot be a list or a dictionary, and two keys cannot be equal. There can be at most one value for any given key. The first restriction is tied to Python's underlying implementation of dictionaries, and the second restriction is part of the dictionary abstraction, which is that it's supposed to give you the value for a key. If a key were repeated, then there wouldn't be the value for a key, because there would be two. So dictionaries are all about finding the one value for a particular key. If you want to associate multiple values with a key, store them in a sequence, such as a list. You can also build a dictionary using a dictionary comprehension, which is a compound expression in which you write down what the keys look like, what the values look like, and as a source, you write down some iteration expression which gives you a sequence from which to build key-value pairs. You can filter some of them out, and in order to refer to how to construct the keys and values, you can give a name to each element in this iter expression. The final part about the filter expression is optional, so there is a short version of this that leaves that out. This is an expression that evaluates to a new dictionary using the evaluation procedure of adding a frame with the current frame as its parent, creating an empty result dictionary that is the value of the expression, and then we fill up this dictionary before the expression is fully evaluated for each element in the iterable value that you get by evaluating this iteration expression. You bind the name to the element in the new frame from step 1. So name now has a value, one of the values in this sequence. And then if filter expression evaluates to a true value, add to the result dictionary an entry that pairs the value of the key expression to the value of the value expression. Let's take a look at a dictionary comprehension. This says x squared is associated with x for every x in 1, 2, 3, 4, 5 if x is greater than 2. X is going to be bound to 1. X is not greater than 2, so that one gets skipped. So does this one. But this one is greater than 2, and so we add a key value pair from 3 squared to 3, and that's what we see in the output. We also do this for 4 and 5, and we end up with a dictionary that maps various numbers to their square roots by evaluating this large dictionary comprehension. I think it's worth trying to use one of these in an example, so here we go. Let's implement the index function, which takes a sequence of keys, a sequence of values, and a 2-argument match function. It returns a dictionary from keys to lists in which the list for every key k contains all values v for which match kv is a true value. When you say a dictionary from keys to lists, that means each entry in the dictionary is going to have one of the keys, and the associated value will be a list. So what this is saying is build a dictionary with all these keys, 7, 9, and 11, and that's what we see here in the example. The values are drawn from the list that's provided, a range from 30 to 50, but the list for each key is just the elements of this range for which this function returns a true value. This function says for a key and a value, only return true if the key evenly divides into the value. So if value is a multiple of the key. So this is meant to return a dictionary in which 7, the key, corresponds to a list of all the multiples of 7 within this range. And so on for 9 and 11. This is a natural application of a dictionary comprehension, where in fact the keys we want are just provided to us in the keys list, so there isn't actually a whole lot of work to do in order to figure out the key expression. It's just k. This K has to match this K, but I could have used a different letter. It just seemed like K was a good one based on this description. Now, how do we construct a list of all the values within this list of values that match the key K? Well, that's an example of a list comprehension. Give me all the V for V in values if it's the case that match KV. Notice that since this list comprehension is within this dictionary comprehension, this expression right here can refer both to V, the value, and K, the key, and do the matching. And now we're done implementing this function.